All right, so one of the first things that I wanted to show you guys tonight was just some additional mate options that are out there. Um, so actually, let me tell you what, let me bring in a third beam, or at this point it's easy enough to just do a copy and paste and give myself a third beam out there. So let's say I've got these beams, and hypothetically, I am trying to line up these first two beams, keeping them glued down or tied down to something, and have this beam rotate around the back hole. Like I've got a pin going through or a long screw or something. In fact, let's do that. Let's see if I can find a nice long screw here. What's the longest screw I've got? 1.5 inch or 1.25. It's not very long. Let's try it though. Okay. So I go ahead and I mate the top two with a coincident mate. Cancel. What did I do? Clear selection. Mate the top with a coincident mate. What in the world?
You did the coincident mate to one of the edges, not a face.
I sure did, didn't I? All right, face. Face. Coincident mate. That's what happens when you go too quickly. All right, I want to line up this hole on these two with a concentric mate. And now I'd like to set these two apart about the distance of this, which is 1/4 inch. It's 1/4 inch thick. But I don't want these things actually touching. So let's say I'd like to make these things set apart by 0.3 inches. And I can do that with this distance mate right here. So if I click on that face, then click on this other face, see, it's defaulting to a coincident mate. Now, actually, this is one of the first things that I wanted to show you, which is when you have two parts or two features selected, and you've probably already seen this, the available mates are highlighted different than the ones that you cannot select. I cannot choose those two faces and then say make a tangent mate. Tangent mate is just completely unavailable. So it's always good to notice that, just in case you're trying to do something, and which is what happened to me earlier, you select the wrong faces or the wrong features on the parts. So always be, or that's something that you can look for when it applies. But at this point, I'd like to make this a distance mate, and I said I wanted to set them at 0.3 inches apart. So when I do that, this is my primary piece. This is my fixed beam right over here. And now this beam is fully defined, and it can no longer be moved. And I've got it defined, of course, by the top edges. The top faces are set with a coincident mate. The back holes are set with a concentric mate. And then I've used this distance mate to set up this distance of 0.3. All right. So to take things a little bit further and to make sure it actually looks like it's making sense, I'm going to set this screw in the middle here. So that screw now is set in with a concentric mate. And I'm also going to set this other beam with a concentric mate on there. Now, again, I've got this thing. It's a little loose inside here, and that's fine. But I'd like it not to move around so much. Okay? Now, we just saw a distance mate where I can set up the actual distance. So I could set this thing up so that it is perfectly centered in between here. But I'm going to show you the first of the advanced mates right now. What if I wanted to allow this floating ability, but not allow it to actually crawl into or cross into the space of this other beam? So I can do that with what's called a advanced distance mate. So here what I'm going to do is select this face, select the face that it's really close to, and then using this advanced distance mate, I'm going to say the advanced distance mate gives me the ability to set up a minimum and a maximum value. So I'll set up the minimum at 0, and then I'll set up the maximum at what? 0.05. That should be right. So now, as I try to pull this piece into, as I try and pull this beam into this other beam, it stops me. And that's a mate. And it'll slide back and forth on here. And it'll get to this point, and it's not this other beam. It looks like the other beam is what's physically stopping me. But what's physically stopping me, as we could see, is this mate that I set up that is a limit distance mate. So it gives me that ability to allow parts to move, but constrict their movement in some way. Okay?
What?
Yes,
Why
sir.
did you choose 0.05?
0.05, because I knew from the math this is a 1/4 of an inch thick. The beam itself is a 1/4 of an inch thick, and I set the distance in between this beam and this beam at 0.3. So if I take 0.3 and subtract 0.25, a 1/4 of an inch, that equals 0.05. So
okay.
that's my maximum distance here, is when I get 0.05 away here, then I'm touching the other beam on the other side.
Okay.
Got it?
Yeah.
Okay. So now I'm going to show you what if I want to constrict the movement of this piece by angle. All right. So the first thing that I do have the ability to do is I can set an angle. So if I actually look at this face here and then choose one of these other two faces, I can set this thing at a perfect 45-degree angle. So select that face, select another face. Notice it's automatically assuming I want a coincident mate, but I don't. I want an angle mate. Notice also the angle and the distance mates, even though they aren't selected, they are telling me, look, here's the angle this thing was set at when you first came into this dialogue. I thought that was cool. So if I select this, notice it goes right back to the exact orientation it was in before, and it's telling me, look, that is a 28-degree angle. Well, I want it to be at 45. So I change it to a 45-degree angle and lock it in. And now this piece is locked in at a 45-degree angle. It can still slide back and forth according to that other mate that we had added, but it's locked in at a 45-degree angle. Okay? Now, what if I want to take this to the next level, and instead of having this thing locked in place, And let's just assume I have something physically blocking the bottom, and I've got something physically blocking it at 90 degrees. Okay, and you can just imagine that we've actually built the structure around all this that makes that that in the physical world makes that happen. But we want to know, how am I going to model this inside SolidWorks? So the first thing we're going to do is get rid of this mate, because that one is holding it at 45 degrees. So if I come back into the mates and again select two of these sides, I'm sorry, two of these faces, the top face on the beam that's moving and the top face on one of the beams that's locked down, and then go into the advanced mates, now I've got, just like we had with the distance mate, where I can set up a minimum and a maximum value, I have that exact same scenario here. I can set up a minimum and a maximum angle. So let's say I want to change it to 5 instead of 0 as my minimum and allow it to go to the full 90 degrees. Now when I lock that mate in place, I can bring this piece down to that point. Right there, it is being stopped. And boy, that would be perfect. If I had a screw right through this hole right here, it'd be like this thing is being stopped right there by that screw hole. Maybe a couple of extra, maybe 4.5 or something would have been more perfect. But then when I try and bring it back, I'm stopped at 90 degrees. Okay. So now we're starting to see not only how we can allow for movement inside of our SolidWorks assemblies, but also how we can limit that movement. Obviously, in the physical world, we would have something in place, that some kind of a stop that's keeping this thing from going past this point. But as we have seen with SolidWorks, you need to create the model conditions that say, okay, I don't want it to go past, because SolidWorks will let two pieces coexist in the same space. There are ways that you can check for that, but those ways, one are a little bit above and beyond the things that I want to cover at this point, and two, the rules inside SolidWorks that check for two pieces that are coexisting, or two pieces that are what's the word that they use? The conflict when they hit each other. That is actually more work on SolidWorks than setting up a mate. So if I were to have a physical piece here and I told SolidWorks, look, let me know every time I run into that piece, that is much more strenuous on your computer system than just setting up the mate to say, hey, limit the angle. Limit the angle so that this thing cannot go past 90 degrees. Okay? So as you see underneath here on advanced mates, and John, this is a great thing in Siri 2. This is a great thing that you can use these videos, these training videos out here on my SolidWorks, or even go out onto YouTube. Just do a Google search and say, how do I set up a profile center mate? Because I don't know. But if that's something you want to explore to find out where that would be used and what would be the reasoning behind it, go out there and explore and find. The ones that I've shown you here, the distance and the angle mates, are really the only two underneath advanced mates that I have used. I have used the linear coupler mate, but again, I'm not going to get into that one during this session. But some of these you might explore and find out there's good reasons to use. Okay, so at this point I'm going to go ahead and